I'm starting here with a 2" by 2" by 1" raw stock. I essentially took a chop saw, eyeballed it. Pretty good eyeballing, I think. But anyway, 2" wide, and then this is a long rectangular uh, bar stock from Master, aluminum 6061. And the end goal is to get to this optics fixture. It's compatible with 30 millimeter ThorLabs cage system, if you're familiar with that. Really useful. This is just a fixture for / heatsink for a laser diode. And so, relatively new to the Tormach, so I kind of just wanted to walk through the feeds and speeds of the different tools that I used. So the first tool we'll go through here on this setup is Tormach 1.5" face mill. And so for that, I'm using this face mill here. Turned out to be really helpful. Still not getting, I think, a lot of the probably intended use out of it, but I did get comfortable with using it on aluminum. And so this walkthrough is just kind of, here's what I decided to use, and is what worked for me, although it was incredibly slow, but it took a few times. I ended up getting the tool stuck, but eventually and it did end up working. On these first two faces, with tool 21, I essentially am just going to the raw stock top, making sure that I'm effectively there. With phase 2, I'm taking off. That's just at the top. Phase 2, I'm just taking off the top little portion that is not associated with equal facings on phase 3. So phase 3, like I said, is just very slow facing of the raw stock. I tried a few feeds and speeds before this and just kept getting the tool stuck. Here's what the getting stuck looks like. This is what I'm referring to. I'd used a 3/8" end mill, I think 3-flute chip breaker that I was using to help extract the chips better, that worked on the previous project, but not here. I was trying to take off, I think, about close to a 1/4 inch off the top. I got stuck, and then that happened. So this is what led me to the face mill, which ended up working, although real conservatively and took forever. But this is the reason for moving over to the face mill. So I kept getting the tool stuck, and eventually, trying 4,000 RPM, 25 inch per minute feed rate. But I think what ended up finally helping me use the tool and start to take all this material off is multiple depths, with a maximum step down of 0.0125. And then I make sure to check this. This also was kind of key, I think. Just this could probably go up a bunch, but I think I was starting with half the tool diameter, which is cut, point. I think I was doing like 0.8 inches step over, and didn't like that at 4,000 RPM. And so just kind of went a little drastic, down to 0.1875, and it finally worked along with these multiple depths. Downside there is you're looking at about 40 47 minutes of runtime. But it worked, and it's a single piece, so time's always important, but I kept getting the tool stuck, so I finally got something to work. I'm sure I could improve on this, but this is kind of just a start. So then, next tool that we're looking at is where did I get? Is Kennametal, 3/8 inch flat end mill. I think it's 3 flute, and didn't have too much in terms of problems with running this one. I think I was still relatively conservative after having tools get stuck with the shell mill. Just, it was getting tired of having to put in a new working material or raw stock, and so the setup takes forever. So I just wanted to help avoid doing that. And so here are the tool parameters. This one I ran at 10,000 RPM with a cutting feed rate of 15 inches per minute, and did a similar approach here. Yep. Multiple depths. Again, 0.0125, probably overkill, but tool didn't get stuck or break. And so that was good. Let's see here. Okay. So then next step is, okay, so next step is a pre-drill of all the holes that are essentially existing in this fixture. I went with I wanted to just avoid having to put in multiple drill bits in here, so I went with the smallest drill bit that I could use, which ended up being, let's see, tool 3 is 0.1772 Kennametal drill bit. And look in the video description. I'll try to put links to each one of these tools. But this was the first time. So for the milling of the actual through holes, I decided to use this 1/8 inch end mill, and so I hadn't worked with anything that small before, so I wanted to help it out a bit, and so I just decided to do the pre-drilling. So relatively straightforward. I think I went down, let's see, it's probably overkill, but went down a 1/4 inch below model top. This model depth is 4 millimeters, so 0.15748 inches. So about, 0.1 inch depth past the part, which again, probably overkill, but just wanted to make sure that I got all the way through. Okay, yeah, so for the through holes, so tool 4, wait, I should show this one. This tool I got from Harvey Tool. It's a Harvey Tool end mill that I got from MSC. And again, I'll put the links to this in the description. But this essentially is a two flute solid carbide. Again, I hadn't worked with anything that small before, so that's why I did the drill bit lead holes. And again, took a very conservative approach. So 8,000 RPM. This high setting on the Tormach 440 tops out at 10,000, just for reference. And cutting feed rate 6 inches per minute. So here again, multiple depths, taking it real slow. I really didn't want to didn't want to break the tool or get it stuck. I think at this diameter, it'd probably just break before I got stuck. Um, yeah, so just super tiny step over point, about 6 thousandths. Maximum roughness, roughing of 0.0125. Got to be a little patient with this one. Just this alone takes close to an hour. But I got it on the first shot, so it beats having to cut some more raw stock and try another attempt. So it took a little longer, but I was able to get it on the first shot. So then I stuck with that same tool and did a little pocket here. Similar approach, just real slow. Didn't break, so that was nice. This is just slightly larger than the 1/8 end mill, and then just finished it off with the chamfer. I haven't had any real problems using the chamfer. I should note, just for the sake of showing the details here, this is a Kennametal 1/4 inch 45-degree chamfer. Never had any problems with this one. It's really nice. It's double-ended, and I think I just went down on depth. Yeah, just 10 thousandths, and so then I, for the back part, just do a whole new setup, enter the raw stock dimensions, and then if we flip this over, again, super conservative. This one took hour and a half. Essentially, I took the same settings from this top face, but it's about 0.625 inches that we're taking off, so it took a while. And then again, just finished it off with a chamfer. So really conservative. Probably can probably go a lot faster. A lot of details I can speed up, but for being relatively new, I just kind of went really conservative. I'd gotten the tool stuck, I think maybe 3 different times. I just got tired of that and throwing away blocks of aluminum, so just took it really slow and got it to work. Not perfect, but the other issue is that the top of the model here is only about 30 thousandths from the top of the vise. That's just mostly a limit on the parallels that I had that I'm working with, and so I got super close to the vise, which is not recommended. It was a little scary, but the other thing is these holes. When I flipped the part over, I did the offsets. I have a probe that uses we set the X, Y, Z coordinates. Probably off by about, actually it's hard to tell, but it's slightly off here on the holes, but it actually fits into the cage system that I have. So for now, that's all that matters. And so we'll call that a small win and a success. Thanks. Hope you found this useful.